Hello and welcome to the Rabbit Hole Podcast, the podcast where we talk about the most wild, strange, and craziest conspiracy theories you have ever heard of. Many of you are probably super familiar with the conspiracy theories that we've talked about, but we're going to be getting interviews with people who are deep diving into these conspiracy theories and talking to them and getting to know a little bit more about the theory themselves. And then simultaneously, I will be posting a recap of my research after the interview has been conducted. Today, we'll be talking about the Flat Earth conspiracy theory with Dave Weiss. He has his own podcast and channel that you can find on YouTube, and I will have it linked below. And he has done this interview with me. We had the documentary that we conducted about a year ago on the Flat Earth conspiracy. You can go ahead and watch that too. It's on our channel. It's about 30 minutes long. To see the full interview with Dave Weiss, you can go ahead and go down to our links below, and it'll be linked in the description. So let's go ahead and dive in to what we talked about during the interview and some things that I found that I needed to do a little bit further research on. Starting, let's talk about the argument of the Earth's curvature in reference to how we can still see things over the horizon. Here is a clip from the podcast itself.
So in this video, we show that the camera is only 6 inches off the ground, which would require, according to Earth Curve Calculator, the horizon for that camera the Earth should start curving away and at less than a mile. I think it's 0.88 miles, less than a mile from 6 inches, right? So he went and put these 4 lights out here. And this one's at 8 miles, 7 miles, 6 miles, and 5 miles. Now, again, doesn't sound like a lot, but the globe is requiring there to be a certain amount of curvature. And if we add in magical refraction, I call it magical refraction because no one has ever taken something behind a physical object and made it refract up and appear to show at eyes level, right? But all of them just show up, and adding an extreme amount of refraction that globers don't even claim is real, this should be 30 feet below the curve, 22, 15, and 9. But for some reason, they're all at that same levels.
After I did a little bit of research, I found the actual numbers for what the Earth's curvature is per mile. And at 1 mile, it drops 8 inches. At 2 miles, that 8 inches is then turned into 32 inches. So at 2 miles, it drops 32 inches. At 3 miles, it drops 72 inches. This is all an approximation, obviously, and it's derived from the Pythagorean theory. If anyone remembers doing that in math, I remember and I hated it, but this is where that is all derived from. Moving into what's the deal behind refraction, and this is really the idea that everyone brings up, and Dave even brought it up with the explaining how we see things over the horizon and how people who believe in the globe seem to use this idea of refraction, to explain why we can see things at such a long distance, especially over the sea. When I Googled it, it says atmospheric refraction is the bending of light rays by density changes in the Earth's atmosphere, causing objects to appear closer than they are. For reference, when he showed the boats on the ocean or when he showed the lights in his experiment, it kind of makes an understanding of why we were seeing things the way that we are. And it's really refraction at the end of the day, because it's bending light, it's density changing, and then the light is bending downwards. Objects seem raised almost. It was shown within the video clip that he showed of the boats, or example that he showed of the boats. It appeared to be higher than where we were looking from, but this is all due to, scientifically proven to be due to refraction. Next, I was really interested to look a little bit more into why the sun seemed to fade out in the video clip that Dave had presented. Here's that video for reference.
So the sun was going down, 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 and then it stopped. and it just sat there. I have this frozen for a second. I'm going to turn on a second. Now, my friends are at the beach over here.
Mhm.
They saw the sun set 10 minutes ago from the bottom up, just like I showed you in all of those perspective examples,
Yeah.
right? Because they're looking out over the water about 10 miles away. There's mountains, in the distance, but there's a shoreline and the cloud deck, and the sun just goes beyond it, just like I showed you. But I got my drone in the air. It's 32 degrees out. There's no humidity. It's super clear. I'm looking west and I watched the sun. It went down, 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 and then it stopped. I don't care if it's out of focus or not. It stopped going down. And what it did, this is super sped up, like 2,500 speed. It took about 5 minutes, but the sun should have gone right below the horizon, but it didn't. It just faded as it got farther and farther away. Its light couldn't push through the soup of the atmosphere. Its light is not that powerful, doesn't travel forever, and it literally just faded into nothing.
Yeah.
That's impossible on a spinning globe.
So, in doing further research, scientifically, the sun does not, quote, fade out, as it seems to be doing in that video. That is almost a illusion that is perceived, but it's rather due to it setting below the horizon, and it's due to the Earth's rotation. It's also due to atmospheric refraction, like we talked about before, and it could be to a number of different things. It could be to clouds being in front of it, it could be to a haze, it could be to smoke or pollution, but the sun, in fact, does not fade out, and it is scientifically proven to just be refraction. The next thing that I really wanted to look into was the fact that he talked about NASA not having any real photos of the Earth itself. And I just thought this was a little bit crazy on my stance, just because we've been taught in school for so long and been shown pictures that were supposed to be from NASA. And I know that it is not just NASA showing us these pictures and taking these pictures, it's also the Soviet Union back when the moon landing and space expeditions were happening. But when you look into it, it does say that NASA has captured numerous real non CGI photographs of the Earth from space dating back to the late 60s and 70s, were when the first pictures were widely taken and recognized. Um, Examples could be the Apollo missions. So, Apollo 8, 11, and 17 captured some of the most famous Earth pictures. The Earthrise photograph was Apollo 8, and it was taken during the first cruise mission to orbit the moon in December of 1968. And this image was shown the Earth appearing over the lunar surface. And then there was the famous blue marble photograph, which is from the Apollo 17 mission, and this was taken in December 7th, 1972, showcasing the full lit blue and white planet that we know as we've seen in pictures and textbooks today. Um, Again, just to play a little bit of devil's advocate, we really don't know for a fact if these are real or not, or if someone's lying, or if we're being deceived, especially with AI and CGI the way it is today. We really just have to take everything with a grain of salt. But here is a short clippet of a video off of Earth Observatory by NASA.
For nearly 60 years, astronauts have been looking down at Earth from space. And all along, they've been shooting photos. They've been doing so almost daily since November 2000, when the International Space Station became a permanent home to astronauts.
We're over 3 million images in the archive. It is perhaps the longest continuous remote sensing record that we have for the Earth's surface.
Moving forward, the next thing that I genuinely agree with Dave on, and I couldn't unsee once he showed me, and I tried to do a little bit more research and find out why things look the way they did, and everything just really isn't adding up to me, is the Hubble capturing vivid auroras in Jupiter's atmosphere. And I'm going to go ahead and insert the picture now, but you can see that it clearly looks like AI. It's a little bit hard to see this image and believe that it's true when it genuinely looks like someone just put in a little bit of editing skills and gave us this image, which I'm showing you from the NASA website. And also, when he talks about the planets looking the same as they did from years ago, it kind of made me think, because it was like, I really haven't seen any change in these images. And how is that even possible if we've gone time in and time again and not seen any change, especially with the gaseous planets, because it's supposed to be storms and gases that are the swirls that we're seeing in these images. And it's kind of just like, how has that not changed? Because our atmosphere changes literally every day. So I did a little bit more research on that, and the outer planets such as Jupiter, Saturn, Uranus, and Neptune, these are all the gas and ice giants, and they do experience changes in their atmosphere, but it's generally very subtle. The Hubble Space Telescope has documented changes in the shapes and sizes of Jupiter's red spot over a decade, and they're just too small for our eyes to notice. So logically, this does make a little bit of sense, but I cannot get past the NASA picture of the auroras in Jupiter's atmosphere. Honestly, it just looks a little fake to me, and it it feeds into the theory, in my opinion. Moving forward, I kind of questioned Dave about how the seasons work in a flat earth perspective, because we all know with the sun, it's the tilt on our axis and the way that we're positioned in orbit is what causes us to have these differing seasons and differing temperatures, not only in wherever you live, but also in the hemispheres that you're in. If I'm in Virginia right now, it's going to be fall, but then if I'm in Argentina or I'm in Chile, it's going to be closer to springtime for me. So I was just a little bit interested to see how he was going to chat about this, and here is a quick clip.
Yeah. Well, then
Now,
argue with the days getting shorter and longer, like with the there's
yeah,
like the shortest point in like December. I don't remember exactly. It's like December or January. It's like the shortest point, and then there's another one that's like the longest point, like
right.
days longer and shorter. How do you
Well,
explain?
our days are longer in the summer because the sun is closer to us. You can only see the sun at a certain distance away, and then its perspective hides it.
Mhm.
So if the sun is closer to you, you're going to see it for a longer period of time. If it's farther away, you're not going to see it until it gets closer, and then it's going to disappear before, it's going to disappear earlier. It's going to show up later and disappear earlier.
Now, for reference, with a little bit more of my research, I found the exact numbers for why the seasons occur on Earth, and it is because of the tilt on its axis, which is about 23.5 degrees as it orbits the sun. We can see in this video that from Kirk for News with Alex Libby. He's a meteorologist. He's going to go ahead and explain a little bit to Dave's point about why the Earth is closer to the sun in the winter than it is in the summer.
Hello everyone, I'm meteorologist Alex Libby, and in this video we're talking about how we are the closest to the sun today, January 4th, 2023. And that occurs because the Earth's orbit is not a perfect circle. During parts of it, we're closer to the sun. During other parts, we're further away. And in January, in the northern hemisphere, in Arkansas right now, we are closer. We're 91,403,034 miles away from the sun. In July, early July, July 6th, we're over 94 million miles away from the sun. And you might be thinking, why does this happen during the winter? Why does it happen during the summer? Why are we furthest away during the summer? Why are we closest during the winter? Well, it's because that difference is only around 3 million miles, which sounds like a lot, but it's only about 3% of the distance. So overall, it doesn't really impact our temperature that much. What does impact our temperature, which we know, is the seasons. It's the tilt of the Earth. When we're tilted towards the sun, which we are during the summer solstice, we're seeing a lot more sunlight than when we are tilted away from the sun during the winter time. So the tilt overall has a lot more impact on our temperature than the distance from the sun. But that distance has a little impact, probably around a 3% impact. So 10,000 years from now, in the year 12,000, we will be closest to the sun in our summer here in the Northern Hemisphere. So that might make our summers just ever so slightly hotter than they are now, which would be the opposite in the Southern Hemisphere. Their winters might be a little bit cooler. So I hope you learned something cool here. 3 million, you can tell your friends we're 3 million miles closer to the sun in the winter than we are in the summer.
Just going off of that clip, it really comes down to the Earth's orbit and the axial tilt. Now, he did a really good job of explaining it better than I can because I am clearly not a meteorologist, but science-wise, that kind of makes sense why the Earth is the way it is, why it heats the way it does, and it also alludes to moving forward with why the question of why we are not freezing during sunrise and sunset. So after my research, I looked a little bit more into why we're not freezing during sunrise and sunset, because Dave had a great point. We would lose a certain amount of heat every day, and it's just kind of questionable as to how, with the Earth tilting the way it does and our position to the sun, how we are not freezing at sunrise and sunset every single day. And honestly, when I did my research scientifically, it comes back to residual heat, like we talked about in the video. And also atmospheric installation, which I know Dave had pointed out us being in almost like a container, which is almost verbatim what an atmospheric insulation would be. The atmosphere absorbs and retains heat, which is what continues to be almost like a blanket for us in order to have not extreme drops in temperature at the beginning and the end of the day. The next thing that I really wanted to research, and I had heard of them before, was the idea of the analemma. So the analemma is a really cool thing that you can do where you have to be very strategic and very time conscious. But if you go outside every day and you take a picture of the sun at the same exact time every day, the sun, over the course of a year, the sun will end up coming, when you put all of the images together, it'll end up showing in the shape of an analemma. An analemma is this. So I did a little bit of research as to why the analemma works the way that it does with the sun, and just kind of trying to explain it in a globe perspective. We heard Dave's perspective on why it is with a flat earth perspective, but from a globe perspective, I wanted to understand a little bit more as to why it is the way that it is. And what I found is this video from a YouTuber known as Spaceman Steve, and he is an astronomist in Hawaii, and I'm going to go ahead and play about a minute or so of his video so that we can better understand why this works the way it does from a globe perspective.
What's the deal here? Why are we looking at a figure 8 in the sky? Well, each day the sun traces a lovely arc across the sky as it rises in the east and sets in the west. If you live in the northern hemisphere, the sun will appear in your southern sky. And if you're in the southern hemisphere, the sun will appear in your northern sky. Throughout the year, the height of the sun changes. In the wintertime, it completes a small arc across the sky. The smallest arc occurs on the winter solstice, which takes place on December 21st in the northern hemisphere and June 21st in the southern hemisphere. You might know that on this day we get the shortest amount of daylight throughout the year. And this occurs because the sun is above the horizon for the least amount of time. Over the next 6 months, the height of the sun increases until the summer solstice on June 21st in the northern hemisphere and December 21st in the southern hemisphere. The reason for these changes are due to Earth's constant tilt. We are tilted at 23.5 degrees with respect to our orbit around the sun. When we are pointed towards the sun, we experience summertime. And when we are pointed away from the sun, we experience wintertime. In our analemma, we can pick out the solstices, when the sun is lowest or highest in the sky at the same time of day. This analemma was photographed in the northern hemisphere. If it were done in the southern hemisphere, then the small loop of the figure 8 would be down at the bottom. The angle of the analemma changes with your latitude on the Earth.
Now, looking at all of this, it is not to say that the globe perspective is correct or to say the flat earth perspective is correct. Honestly, at the end of the day, all I'm trying to do is give a valued perspective from both sides. There's still things that could be questionable. Can we really trust the government to tell us the right things? NASA is not necessarily a government organization, but can we trust that NASA is telling us the truth and showing us the truth, especially after seeing the photograph of Jupiter? I begin to question more and more after talking with him. I would not say that I believe in a flat earth perspective, but I definitely question some of the things that we're presented with, especially in textbooks or the photos that NASA has given us. And it just makes you think, and it leaves you with a question at the end of the day of, are we really being told by major corporations what the truth is? So I leave you with this question and to ponder and think and explore both sides to understand completely what we're seeing, and you can pick if you believe if there's a flat earth or if we are truly on a globe. Next week, we will be talking about Big Pharma or Big Liar with John Julius, my dad, actually. And we will continue to go on our deep dive in the rabbit hole as we talk about the pharmaceutical organizations and corporations and how the government and FDA have made the regulations that they have, and why the United States is the way that it is in comparison to the rest of the world health-wise. So make sure you tune in to see that video and the recap from that video. And also, if you like this video, please leave a like below or comment what you liked most or what conspiracy theory you would like to see coming up. And if you enjoyed this content, make sure to subscribe or follow, and follow us throughout this journey, because we will have 8 weeks continuing of many, many more conspiracy theories to chat about. You can also listen to this on Spotify or YouTube, depending on what platform you are using now, and keep up to date on Facebook, Instagram, and TikToks, which handles will be linked below. Thank you, and I look forward to our deep dive next week.